Here in Algebra 1, after we learn all about adding, subtracting, multiplying, and dividing with polynomials, we do a little bit of review before final assessment. So this will be all about reviewing and how to handle the different mathematical processes to solve these problems and equations. So the first problem, perimeter of a triangle represented by the expression 5x squared minus 10x plus 8. Write a polynomial that represents the measure of the third side. So here we have this side is 3x squared minus 4x plus 5. We have x squared minus x minus 4. And we get the whole thing of 5x squared minus 10x plus 8. So the question becomes, how are we going to figure out really what the third side is? So we can first add these two sides. So if I take this side and add this side, I just go straight down the line. X squared plus 3x gives me 4x squared. Negative x plus negative 4x gives me a negative 5x. And then a negative 4 plus 5 gives me plus 1. So here we have how far we have from around here, these two sides so far. So if the whole thing is 5x squared minus 10x plus 8, we have to get rid of these two sides in order to figure it out. So we're going to subtract our answer from what the whole way around is. So the whole way around is 5x squared minus 10x plus 8. And we are going to be subtracting the 4x squared minus 5x plus 1. And again, we're subtracting everything. So we have 5x squared minus 4x squared. So that's just going to give me 1x squared. And now we have negative 10x minus negative 5x. So when I subtract the negative, I really end up adding. So negative 10 plus 5 is going to give me a minus 5x. And then 8 minus the 1 gives me a positive 7. So this is our third side. Number 2 is a little bit odd. We have a big parcel of land here. Father owns a plot of land, wants to give his son some land as well. Gave his son equal parts of his land, shown by parts number 1 and 2 here. So these two are the same. All three sections are squares. If the sides of the squares are represented by, squares 1 and 2 are represented by 2x, we need to express the area in terms of x of the sons, the fathers in terms of x, and the area of the entire land. So 1 and 2, the sides are represented by 2x. So I can actually go around and label 2x, 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 2x. So we already got 2x on this one, 2x, 2x, 2x. So we got all that. So this means if this part is 2x, this part's 2x, that means 4x. So if they're all square, that means everything here is going to be 4x. So the area of each son, area is length times width. So length is 2x, width is 2x, so 2x times 2x. Well, 2 times 2 gives me 4. X times x is x squared. The father's land, we're going to use the same formula, length times width, only in this case, they're both 4x. 4 times 4 gives me 16. X times x is x squared. So now we need to express the area of the entire family's land in terms of x. So we just found out that the area of the dad's land is 16x squared, and the area of each individual square is 4x squared. So to figure out the whole area, we just add them all together. So 16x squared plus 4x squared plus 4x squared. 16, here when we're just adding, we just add the numbers and we bring along whatever the variable is. So 16 plus 4 is going to give me 24x squared. Here we have the polynomial 6x plus 5x to the fourth minus 9 plus 2x squared, and we need to find all of these things. So in order to do that, we need to put this in the proper order. Again, we go from highest exponent to lowest. So starting on the line, I see 5x to the fourth is the highest exponent. and then 2x squared is the next highest, and then 6x minus 9. So that's what we're actually dealing with. The leading coefficient is the number that's out front of the highest exponent. In this case, it's x to the 4th. Leading coefficient is going to be 5. The constant term is the solid number in our problem that has no x's attached. So x to the 4th, x squared, x, none. So constant term is minus 9. The degree is the highest exponent, so 4. And the type of polynomial, we just count the number of terms, 1, 2, 3, 4. So that means we have a polynomial. Because remember, one term is a monomial. A binomial means 2. A trinomial means 3 terms. And then poly means is 4 plus terms. Number 4, we have to be careful of the wording. It says subtract 5a cubed minus 9a minus 3b from 9a cubed plus 4a minus 7b. So we are subtracting. So again, we have to pay attention to wording. We are subtracting this from the 9a cubed. So this means 9a cubed is our total, and we have to get rid of the 5a cubed minus 9a minus 3b. So we go straight down the line. Everything's lined up nicely. So 9a cubed minus 5a cubed is going to give me 4a cubed. 4a minus negative 9a. So again, subtracting the negative, we end up adding. So 4 plus 9 gives me a positive 13a. Same with negative 7b minus negative 3b. So I really end up adding 3b. Negative 7 plus 3 is going to give me minus 4b. So there is the subtraction piece. Simplify all of the following with positive exponents only. So 4x to the 0, again, 0 is only on the x. 0 exponent means that item is really worth 1. So this is really 4 times 1, which is 4. 4x to the 0, notice the 4x is inside parentheses, so that is getting raised to the power of 0, which means that item is strictly 1. Negative x to the 0 in number 7, we see that is the negative value of x to the 0. So x to the 0 is really 1, so we have negative 1. 8, we can only multiply like terms, so negative 3 times 9 gives me negative 27. Erase that. X to the 5th times x. We add our exponents, so x to the 6th, 5 plus 1. Y to the 5th times y to the negative 2, separate base. We add our exponents. 5 minus 2 means y cubed. And then z to the 4th is going to come along for the ride. Number 9, we got to use a little bit of distribution. 5y times 2y to the 4th, 10y to the 5th. 5 times 2 is 10. Y times y to the 4th. We'll add the exponents. Do the same thing, 5y times 7y cubed, so plus 35 y to the 4th after adding our exponents. And now we are multiplying, so we have a negative 4y cubed times y squared, so minus 4, and then add our exponents, y to the 5th. And then negative 4y cubed times negative 2y, so negative 4 times negative 2 gives me a positive 8. Y cubed times y to the 4th. Now I'm going to combine the like terms that we can. I see we have 10y to the 5th minus 4y to the 5th, which gives me 6y to the 5th. And then I have 35y to the 4th plus 8y to the 4th. When I add them together, I'm going to get 43y to the 4th. Number 10, I gave you 3x minus 6 squared. Again, this does not mean I square each individual item. It means I have to expand it out. I have 3x minus 6 times 3x minus 6. Use distribution here. 3x times 3x is going to give me 9x squared. 3x times negative 6 is going to give me minus 18x. I'll do the same thing. Negative 6 times 3x gives me minus 18x. And then negative 6 times negative 6 gives me a positive 36. Combine my two middle terms, 9x squared minus 36x plus 36. 11, we're dividing a polynomial by a monomial, so I have to go down the line. I divide each top item by what's in the bottom. So 3ab squared divided by ab. Well, 3 divided by 1 is 3. A divided by a is 1, so we don't really need it. B squared divided by b is b, because top minus bottom, 2 minus 1 gives me an exponent of 1. Then I'll divide the middle term. Negative 4a squared b divided by ab. So negative 4 divided by 1 gives me minus 4. A squared divided by a is a. And then b divided by b is just 1, so I don't really need it. And then last but not least, we have ab divided by ab. Dividing something by itself means I have 1. So I end up with 3b minus 4a plus 1. Number 12 is a monomial divided by a monomial, where we got a whole bunch of stuff going on. We got to pay attention to our variables, our exponents, all that wonderful jazz. So first things first, I will divide negative 21 by 18. Both are divisible by 3. So we end up with negative 7 over 6. Once I divide it out, and then I look for my x's, I see I have x cubed divided by x to the 7th. And anytime I'm dealing with variables on top and bottom, I always ask myself, where is the bigger exponent? The bigger exponent is on the bottom, so x is going to go on the bottom, and I will subtract the exponents. So the difference between 3 and 7 is 4, so x to the 4th. Next up, I look for y's. I see I have y to the negative 5th over z to the negative 4. I ask myself, where is, actually, I had it wrong. It's not z to the negative 4. I have y to the negative 5, and I have y to the 8th. I ask myself, where is the larger exponent? The larger exponent is on the bottom, therefore y is going to be on the bottom as well. Find the difference between 8 and negative 5. So 8 minus negative 5, I end up with 13. And then last but not least, I'll look at my z's. I have z to the 6th over z to the negative 4th. Again, where's the larger exponent? Larger exponent is on top. So z goes on top. 6 minus negative 4 ends up being 10. So I have negative 7z to the 10th over 6x to the 4th, y to the 13th. 13, again, the format's a little bit different. So what we will do is we take a look. We have 3x to the 12th y cubed times 4x y to the 6th z to the 5th squared. So anytime I'm raising something in parentheses, I want to raise the solid number in parentheses to the power of 3. So in this case, 3 cubed, 3 times 3 times 3, 27. Now that I am raising power to a power, in this case, I will multiply. So x to the 12th, I'll multiply 12 times 3. So I get x to the 36. And then y cubed cubed. Again, I multiply my exponents. 3 times 3 gives me y to the 9th. Next up, I will have to multiply, or rather in this case, raise this other set of parentheses to the power of 2. So 4 squared gives me 16. X raised to the power of 2 is going to give me x squared. Y to the 6th squared, I multiply 6 times 2 to get y to the 12th. And then z to the 5th squared, multiply 5 times 2 to get z to the 10th. So here what we can do is we can multiply our numbers. So first up we have to do 27 times 16. So when I do that, 27 times 16 is going to end up being 432. So 432. Separate bases, I'm going to add my exponents as long as they're the same base. So x to the 36 times x squared. 36 plus 2 is going to give me 38. Y to the 9th times y to the 12th. I add 9 and 12, so we get y to the 21st. And then z to the 10th is going to come along for the right. So 14, 15, 16, 17 is all more of distribution, box method, and then 28 or 21 is more of a creating an equation and finding the value of x type of thing. So I'm going to finish it with here because the rest are similar to what we've done in the past. Again, the last four are distribution problems, but this encompasses everything. Zero power, negative exponents, adding, subtracting, multiplying, and dividing with polynomials.